Okay, in this video we are going to discuss about a few problems on series RLC circuits. We consider the natural response of series RLC circuits. Okay, so here in the first question, in the figure below, R equal to 40 ohms. So R value is given, L is 4 Henry and C equal to 1 by 4 farad. Calculate the characteristics roots of the circuit. Okay, which means I need to find out S1 and S2. And is the natural response is overdamped, underdamped or critically damped? So this is a question asked. We need to find out whether the characteristic roots are overdamped, underdamped or critically damped. Okay, so we need to know the three cases. So how do we decide whether it is overdamped or underdamped or critically damped? So those things we are supposed to know, okay, in order to solve this problem. Okay, so I hope if you don't know, please refer to the lecture 1 of unit 4. So there I have discussed the three cases. Anyway, briefly I will tell what are those cases. Okay, I will be calculating alpha and omega naught. These two values I will be calculating. Okay, alpha equal to R by 2L, omega naught equal to 1 by root LC. Okay, those two values, based on these two values, I am going to define the cases. For example, alpha is greater than omega naught. If you get the alpha value which is greater than omega naught, we call that as overdamped case. Okay, we call that as overdamped case. If alpha is less than omega naught, we call that as underdamped case. If alpha is equal to omega naught, we call that as critically damped case. Okay, these are all the three cases we can identify, okay, using the value of alpha and omega naught. Okay, so this diagram may be given or may not be given. So I cannot assure that the diagrams will be given in the question. Sometimes they will simply give R, L and C value and they will ask you to calculate the characteristics roots of the circuit. Okay, and they will ask you to find out the response, what type of response it is, whether it is overdamped case or critically damped or underdamped case. Okay, now let us calculate alpha. We know R is 40, so 40 by 2 times L value is 4 will be 5. Omega naught equal to 1 by root LC, which is 1 by root of 4 times 1 by 4, which is 1. Okay, so in this case I can say alpha is greater than omega naught. If alpha is greater than omega naught, I can conclude that the response is overdamped. What is another question it was asked? Calculate the characteristics roots. So how do we calculate the characteristics roots? I need to find out what is S1 and what is S2. So these formulas also we have derived in lecture 1. Okay, so kindly go through the formulas and write the formulas separately. What are the formulas we need to know to solve the problem? We need to know what is alpha, what is omega naught formula, what is S1, what is S2, and these three cases, what is alpha less than omega naught, what is alpha greater than omega naught, and what is alpha equal to omega naught. So these three cases we need to know. So I'll just put the link of lecture 1 in our description, okay, in this video description, so go through it. So S1 is equal to minus alpha plus root of alpha square minus omega naught square. Substitute all the values, alpha and omega naught, will be getting this value minus 0.101. And what is S2? S2 equal to minus alpha minus root of alpha square minus omega naught square. Substitute the value of alpha and omega naught, which we calculated, will be getting minus 9.898. Okay, so we concluded already, right? Alpha is greater than omega naught. From that I concluded response is overdamped. And there is another evidence which is proving. Okay, so the roots are real and negative. Okay, the roots are real and negative. Usually the real and unequal actually. So roots will be real and unequal. So I can directly consider it as overdamped case. Okay, next problem. If R equal to 10 ohm, L equal to 5 Henry and C equal to 2 millifarad in the figure, find alpha, omega naught, S1 and S2. What type of natural response will the circuit have? Okay, the same kind of circuit, okay, same kind of problem, but it is asked in different way. Okay, they didn't mention what are the responses, what are the cases you have. Okay, they simply find what type of natural response will the circuit have. So you're supposed to know all the three things: overdamped, critically damped and underdamped, and what are the cases for that. So what is alpha greater than omega naught? Just try to remember. Just overdamped case, alpha less than omega naught. Underdamped case, alpha equal to omega naught, which is critically damped case. Okay, so and we need to remember the formula for alpha. Alpha is equal to R by 2L. So R, L, both values are there, so we calculated. And next, omega naught equal to 1 by root LC. Okay, we know what is L and what is C from the diagram itself, or in the question itself it is given, so we got 10. Okay, here alpha is less than omega naught, so I can directly say the response is underdamped. So I am supposed to calculate S1 and S2. How to calculate S1 and S2? S1 formula also we know, S1 equal to minus alpha plus root of alpha square minus omega naught square, and S2 is minus alpha minus root of alpha square minus omega naught square. If I substitute the values, I will get minus 1 plus 9.949J. Here the roots will be complex. For underdamped, the roots will be complex. Okay, you will be getting the complex numbers. The complex numbers means you will be getting imaginary part as well as real part in your answer. And for S2, minus alpha minus root of alpha square minus omega naught square, you will be getting minus 1 minus 9.949J. Okay, both the roots are complex. Okay, we will discuss this problem in the next lecture. Thank you.